Welcome back to the classroom. My name is Mr. Wong. So last video recording, we actually talked about forces on inclined planes. In this lesson's recording, we're going to actually go through some calculation questions in resolving these forces and how to calculate it. So let's get on to it.
All right. So what we have is the best way to start is always draw out the inclined plane you have. It's at 60 degrees. We have a mass of 10 kgs coming down like so. That will be more than enough information for you to work out what the normal force is and what the gravitational force is. Notice I've written down how to find the different components of different forces. There is no real defined horizontal or vertical component anymore, even though I wrote Fy and Fx, but it's just there as a reference point for you to work out all the other types of forces. So working out Fg is just going straight down, so I don't have to worry about trigonometry. Fg is m times g. M is 10 times 9.8. So that's 98 newtons. That's pretty straightforward. We know that the normal force is the cos component of the weight force. So the normal force is the cos component. So cos 60. And this would be equal to, if I just get my calculator out, 49 newtons. Now do remember that the normal force is technically moving in the opposite direction of the weight force. So we could say plus is going down and negative means it's moving up. So if it's moving up, we should also say it's technically 49 newtons. Or you could say 49 up or minus 49 newtons. Up to you which one you want. And there's the answers. The next one is we have Tali sits on a slide so that Kubo can't use it. Why would you do that? Tali has her bare feet against the slide and there is enough friction to prevent her moving. If Tali has a mass of 21 kg and the slide makes an angle of 35 to the horizontal, calculate the magnitude of each force acting on her. Okay, so let's draw that out again. We have Tali here going down 20 kgs times 9.8 and then 21 and then we have an angle. So firstly, there's three types of forces. The first one is gravitational. Gravitational force would be the first one, and that's Fg. So 21 times 9.8. So she has a total gravitational force of 205.8. Next part is her normal force. And we already know that the normal force is just the cos component of the weight force. Don't even need to write that. 205.8 times cos was the angle 35. One six 168.6 newtons. The last thing is we also mentioned friction, okay? So this is part of the skills in answering a question. You need to make sure you highlight or underline each component of the question. This one says friction, and we know that friction is going against the motion down here. So if I know what the value of coming down this direction is, I should be able to work out friction there because it would be equal and opposite. So friction, in this case, is the sine component of the weight force. So we can call it friction. It's just the sine component of our weight force. And that's 188.0 newtons. Now, some of you might ask, why didn't you write down plus or minus in this equation, even though I did last equation? Because the question's asking about magnitude. Magnitude is only asking for a value, not direction. So I can get away with not having the direction written down here. The next bit we have is these two questions, so an object of that, and then I calculate how far it has moved. I'm going to go through this as well. So to calculate the acceleration, remember acceleration is a over fm. This is Newton's second law, so if you don't remember this, please read a book and check again. So firstly, work out the object's weight force. That's always the best way to go. mg equals to 10 times 9.8, 98 newtons. Okay. The next bit is you need to work out the component of it coming down. So it's falling down. You need to work out what's the net force being applied there. So the net force, or the forward force, call that, is equal to Fg sine theta. So 98 times sine 30. So you get a net force or forward force of 49 newtons. Sorry. So if I want to work out the acceleration, it's just the amount of force over the mass, which is 10. So I get an acceleration of 4.9 meters per second, and because it is going down the plane, we can say down the plane as a direction for our acceleration. The next one we have, an object of mass 5 kg is situated on an inclined plane, which is the slope is 45 degrees. This time we have friction acting on the object. Okay? And then last one is calculate the distance. Now this actually needs two things. You firstly need to know the net force, and that would be the force going forwards minus your friction force, which you already have friction force, but you need to work out the forwards force. You need to also calculate the distance the object travels. If you look at any equations we've done so far for kinematics, there is nothing on forces and distance, but we do know the displacement of the object is ut plus half at squared. So we can find the acceleration based off the net force to work out the total distance traveled in 2 seconds. Okay, same idea again, find the weight force. So 5 times 9.8, 49 newtons. We want to find out the forward force, and that is going to be 49 times sine 45. .65 newtons. Okay. The next step we have is to work out what the net force is. And we said the net force is just our forwards force, which is 34.65 minus 2 newtons. If anyone asks why, because the question said so. So the total net force we have is 32.65 newtons. Okay. Acceleration would therefore be 32.65 over 5, because that's our mass. We'd have an acceleration of 6.53 meters per second. So the last bit we have to work out is displacement. Displacement is equal to initial. We don't actually have an initial here, so that's 0t plus half 6.53 times 2 squared. And so the answer would be roughly 13.4 from memory. That's what the answer said. Or 13.06 meters. And that's how far the object traveled down the slope in those 2 seconds. And there you go again. Just a bit of a reference back to that. The last two is where it gets a little bit more interesting. So instead of this diagram we have here, we actually have an object of mass. We have a pulley. And we say that on that pulley, there's another piece of mass that's connected on. Find out what the acceleration of the object is. So is it accelerating this way? Or is it accelerating this way? A clue for you all is we have the weight force of our block down here, Fg, but we also have the weight force of this little block, Fg, down here. And it's because of the force from this little mini block that gives us the tension strength. So the force of the string, or the tension of the string, that's given by this Fg here. So they're equal to each other. So once again, find find Fg. So Fg of 1 is 49. I'll call that number 1 here. Number 1. Fg of number 2 is 19.6 newtons. So we have about 19.6 newtons of tension in that string pulling this object up that way. So what about this motion? What about the forwards motion? Where is that object going? Now we know that theta is 60 degrees. We know that the forwards motion is always a sine component of the weight force, of the big mass at least. So sine component forwards is equal to sine 60, sine 60, so 46 times sine 60, we have 42.434 newtons. If we look at the net force, F net, it's 42.44 minus 19.6, because it is pulling it in the opposite direction. So we get an answer of roughly 23.44 newtons. So the last step is to work out the acceleration. The acceleration is force over mass. Now what a lot of you would probably write down is the net force is 23 here, and that's completely fine. This might sometimes be something that people forget about, and that is the mass. Now, remember, our block here is tied to this block here. So rather than using a mass of 5, because these two are connected to each other, the total mass is actually 5 plus 2. So it's actually 7 kilograms, like I said, because they are attached together as a string, so they identify as one object. So if I find what the answer is, I actually find my acceleration is 3.35 meters per second squared. All right, and pretty much the exact or similar numbers there. Okay, so there we have that. Do apologize. I did make a little error, so this shouldn't be 23 here. Do apologize for that. The reason why it's not 23 was I accidentally typed in 19 rather than 19.6 into my calculator, and so it didn't really quite appear with what I had. So the correct answer here should be 22.84. So it'd be 22.84 over 7. And so that gives us the number of 3.26 meters per second squared. And obviously it goes down the slope because it's a direction. So now we are back in business. The last example we have here is the mass on an inclined plane. And this time we also have friction, and we have a pulley to a weight of mass 3 kgs. Okay? So we do the exact same thing. We already know that the weight force is 49 for the first one, so for mass 1. We know that for the weight force of the second object is 3 times acceleration due to gravity, so it's 29.4 newtons. If I draw it out, it looks something like this. So we have an object, we have friction force, we also have tension force from our pulley, both going this way, and then we have our forwards force going down that way. So again, forwards force is just the component of our weight force, sine 45. .65 newtons. So my net force, we could just say forwards is the main direction we're looking at. F friction and F tension are both moving in the opposite directions, so that's why they're negatives. So 34.65 minus 29.4 minus 2. Total net force is 3.25 newtons. Again, you can find the acceleration as F over m. In this case here, remember they're still attached to each other, so it is 3.25 over 8 kilograms because of 5 and 3 in the question there. So the acceleration is roughly 0.462 0.25 meters per second squared. The last bit goes back to a kinematics equation, v equals to u plus at, because we're trying to find the final velocity after 1 second. U is 0, a we already found, t is 1. So the final velocity after 1 second has passed is roughly 0.406 meters per second. And that's how you do all those questions there. And also, not to forget, it's gone down the slope. So I'll just go down for that case there. Wonderful.
And that ends our lesson for today. Thank you so much for joining. Hopefully, at the end of this lesson, you have developed a better understanding on how to analyze forces on inclined planes and how to solve for those problems. So until next time, I'll see you later.